In this video, I want to show you a tool that can be useful for analyzing circuits. And if you go to Tinkercad.com, it will take you here and you come in and you either join now or sign in. I've already got an account and I'm going to use my school Google account, so I can just click here and it should bring me in. And you're going to get this nice environment where you can do a lot of things. You can do some simple CAD. There's all sorts of stuff in here that I haven't explored in depth. The one right here, circuit, I want to take a look at. So you can see I've done quite a few circuits in the past, and I'm going to create a new circuit here, and I want to show you how to do that. So click on Create New Circuit, and there's all sorts of stuff on the right that you pull over into the left. And also, here's a new thing, discover pre-made circuits to build from under starters. So if we come here, starters, here's some basic circuits that are already built for you. I don't want to use those right now. I want to use different things. So let's go with components, basic, yeah, there we go. So you can see there's a resistor, there's a switch, and here's our friend the breadboard. So I'm going to drag it over here. There it is. And we don't really have to give it a name here, I don't think. So let's build a very basic circuit that we might look at. And I'd rather not use a 9-volt battery. I'd rather have something a little lower voltage, but I am going to use it nonetheless because the other battery options I think are elsewhere. So this is our battery, our 9-volt battery, and what we can do here is, let's see, that is the negative right there. So if you hover, you can see negative and positive. So let's go ahead and you just click here, and you can kind of click over at various points. It's kind of like a spline algorithm, I think, and you can kind of make it look somewhat realistic by making it a little curved. And you can also, let's see, either right click or double click, whoops, on the there we go, we'll get it. You used to be able to change the color here, so how do we do that? Oh, they've changed it. Okay, so it's a drop down now. So there's our red wire, and let's energize our negative rail over here like so. And now I can just come over here. I guess I need to grab it and then change that to black just to kind of keep things straight. So now we've got this this entire rail here sitting at 0 volts, and this rail here sitting at 9 volts. 9 volts is pretty high for some of these circuits that we're doing. So what I'm going to do is I'm going to put a current limiting resistor. Where was that resistor? Here he is. I'm going to drag it over here, and I'm going to just do one thing with this resistor. I'm going to limit the current coming out of this battery. So I'm going to change the resistor to, let's see, quick calculation. I think, yeah, I kind of forgot. So I'm just going to say 470 ohms. So I got to come over, it defaults to k ohms. So let's go to ohms here. So this is going to be a 470 ohm resistor, and all it's going to do is it's going to come from the power rail, and then it's going to, actually what I'd rather do is kind of place it like, I think that's right. Okay, so I've come through here at 9 volts. I force the current to go through this resistor of 470 ohms. So right here, this row right here, row 28, is going to be sitting at less than 9 volts when current flows in this circuit. So this is basically some current protection. And okay, let's start to make our circuit. So what we want to do, let's make what's called a combination circuit. So we're going to come over here take this resistor and I'm going to make him 330 ohms, 330 ohms, and I'm going to rotate him. Well, you click on it and you click this button up here, rotate. Well, goes in what 30 degrees? No, yeah, 30. And I'm going to put him right here. Okay, so now he is going to make connection with the 470. 330 orange brown is going to go here, and that's going to be our path so far. Now at this point I want to break into a parallel circuit. So, well, actually, let me hold off on that. Let me pull another resistor over here, and I'm going to make it a 220 ohm resistor, red, brown, and I'm going to put these guys in series right here. Okay, so the current comes through here, through there, and off to the rest of the circuit. So we have those two in series. Now let's pull another resistor over. We're going to put some resistors in parallel. And this first one is going to be, I think I'm going to make it 680 ohms. So I'm making these a little higher because when we use resistors in parallel, the effective resistance is less than the resistors that make up that parallel combination. So I'm going to make these a little higher, so 680 ohms, and let's see what else. I don't want the current to be too small. 80 ohms. Yeah. So I need to drag a new one over and make it 150. So we have a kind of a big one in 680 and a small one in 150. And I'm going to put this right there. Okay, let's zoom up to make sure we have things correct. So the current comes through here, it goes through this current limiting resistor, and then this is our main circuit. So we go through two resistors in series like this, and from this point these two resistors, the 150 and the 680, they are both attached to the one side of the 220 ohm resistor here. So we're going to go through here, and then we're going to come back home. So to do that, we're going to get a wire here, and we can kind of, use it's a spline basically, so you can kind of make it curved, and that makes it look somewhat realistic. Now, is there a way that we can measure some of this stuff? So how much current does flow in this circuit? I was worried about the current flowing in the circuit. Now I don't have my LED in here, which is the thing I would protect if I wanted to protect something with the current limiting resistor. So we'll put that in later. Let me put in a multimeter. We'll put it right here, and I am going to break open. Let's see, I think I can just come here, grab this, and put this like right here. Okay, and here's my ammeter, so I'm going to set it to A, like so. Now it's an ammeter, so you remember that I have to break open the circuit as I'm just about to do. Okay, this is positive, so we're going to make these leads maybe green and yellow, and we're going to hook them up like that. So green and yellow, just to make them different from the sort of power and ground wires. So this guy, I messed up, needs to go right there. Let's see. So I thought I could just move it. So why doesn't that work? that. There we go. So now I've got it hooked up right there, and then for the other side I'm going to come here in the negative, and it's going to meet up over here on row 4. And so now if we do a simulation here, we should see what happens when we take a 9-volt battery, pretty high voltage for this low voltage stuff, send it through a 470 I think it is, and then 2 resistors in series, 330 and 220, and then 2 resistors in parallel, 680 and 150, and see what we get. And then we'll do the calculation to see if we get the right answer. So I'll hit start simulation, and that's a good number, conservative number, 7.86 milliamps flowing in this circuit. So that's a good thing to know, and when we do the calculation we can compare it to this. This is a good way to check our work. So that is how you use Tinkercad to make some circuits. They give really kind of amazing, random, absurd names to your circuits so you can identify them, and yeah, it's quite a good tool. So I'll stop here, and thanks for watching.